talk about process injection today. So let's get into it. Process injection, I'm talking about remote process injection. So, you know, a lot of tools that I'm Googling for this was a distinction between like local process injection for like shellcode runners or remote process injection. And that's what I really wanted to focus on is remote process injection. So I had two primary goals when I wanted to do this. One of them was just getting familiar with syscalls. I just, you know, more than just reading the blog post, I wanted to write something with syscalls in it. I prefer C#, so that was one goal. The other goal is when I do engagements, I want to have some process injection available to me. And I wanted to have a couple of different methods available and on hand for different engagements. So that's kind of what I went into this building. The TLDR of it is that it's still hard. I questioned whether or not this was worth building a tool or presenting on, but I think it is because I think if you talk to a lot of red teamers, sorry. I think it is because if you talk to a lot of red teamers, for the most part, you know, what are you doing for process injection in the past year or two? A lot of it's like really standoffish, like, we don't really do that right now. It's, you know, so I think there's a little bit of a resurgence with some of the more novel techniques we've seen over the past year. And so there's more interest in doing process injection again. So the then and now of this is, if you think about process injection, what it used to be is like, in the past you would get your beacon, right? And that beacon is a sanctuary, man. You don't do anything in that beacon. The first thing you would always do is inject into something else, right? Go do your stupid things over here so that if you get busted, you still have your beacon, right? And it seemed like overnight, like, have you ever heard the Jim Gaffigan skit where he's about the male seahorse? Like, oh, this is a male seahorse. And the other guy's like, that seahorse is pregnant. The male seahorse has the baby. Like, overnight, we were just all like, no, we never process. You put everything in the beacon, in memory only. Let's run bot files. That's good OPSEC. Like, we were called out instantly, right? And that's kind of what, if you've done like C# based interpreters, you're kind of used to that, right? You're just loading C# assemblies. So I used Posh C2 for a long time because of the C# interpreter. If you're a masochist, maybe you've used Covenant, and that was the same premise, like keep it all in memory, right? These days, though, it's all bot files. Let's run a bot file and keep it all in memory. My hot take, because I have the podium and you guys have to listen to me, bot files are just not that portable. Like, they are, and I'm exaggerating, they're portable, but you get a bot file for Cobalt Strike, and maybe you got to rewrite it for some different beacon header APIs for Sliver or Brutel, and it's not that bad. But then the aggressor script doesn't work either. You have to rewrite that to an extensions JSON, and that's not how Brutel reads it, just because Sliver does. So people like bot files, I don't. I think, like, meanwhile, I'm here with a copy of Rubius from 2020 that I compiled once, and I'm still using it, right? Like, so that's my hot take. I think C# is a little bit more friendly that way. So we talk about, like, why is this, like, hard, right? What it really is security tooling, right? It's just gotten better, and you've got, like, traditional primitives towards process injection that are just being watched closer, right? If you look at, like, the traditional allocate the space in memory, write to that memory, and then execute that memory, that's just being watched super closely now. You could argue, like, there's technically 4 primitives, like you open the remote handle to a process and then these 3, but I already wrote the slide, so it's 3 primitives. The male seahorse has the baby, I guess. Despite it being hard, I do think there's that resurgence because of some of your more novel techniques becoming available. But all of your C2 tooling has really just like 1 or 2 built-in options, right? You've got just traditional vanilla out of the box, like Win API level, virtual alloc EX, write process memory, right? Ring 3 only. And that's cool, but like you can't really use that, right? Because any self-respecting EDR is watching it so closely that it's gonna be blocked outright. Now, if you're lucky, they might have a different option. I usually see like QAPC injection, right? I've also never seen it work because what happens is you get like 10 beacons back and 8 of them are dead on arrival. And then the other two check in once or twice before they die, because like the entire process dies. And it dies because all 10 of the threads just died, right? So you really don't have process injection in your modern C2s. And what that means is you're kind of like, every single engagement, you're left to write it yourself. Call this a hot take, but if you're paying for a C2 server and you can't get anything out of it, out of the box, and you have to write everything yourself, you probably shouldn't be paying for the C2 server. I feel, my hot take, Cobalt Strike is for threat actors. It's malleable, it's extendable, it's great, but out of the box it does nothing. You have to write it all. I used Brute Retel for a little while. I think that's better. I would argue that that's for red teamers. Last 2 engagements I used it on, I did nothing and I process injected. I did nothing and I dumped LSAS. That to me is the key of what we're trying to do. As red teamers, we want operational efficiency, right? We don't have endless time to just do all this stuff. So we need tooling that already exists, that already speeds up our process. And if you're not getting that, but you're paying for it, I don't know, I just don't see the benefit, right? So if I have to write it myself, I decided there's some conditions that I wanted out of it. I want, first and foremost, for it to be portable. I use a lot of different C2s. I used Posh C2 for a long time, right? I use Cobalt Strike when somebody's paying for it. That isn't me. I did try Brute Retel for a while, dabble in Sliver, and right now I'm using Mythic with the Merlin agent. So the point is, I need something portable, because I don't know what I'm going to be using for my next engagement. But I still want to have process injection available to me. And the other thing is I wanted it to be modular, because different tests you're doing, you might not always know what EDR you're up against. And I want to know that I have options available that may work for me, right? So it had to be portable and it had to be modular. There is a little bit of a problem with this. For me, portability means C#. I prefer C#. But there is something that BOF files can do. Yeah, they're portable to a point, you know how I feel about that. But what's really cool about a BOF file is you can be at your client, have a victim out here, checking into your team server, and at your client you can say, I want to process inject, and just kind of slip in the shellcode file, right? And it's going to pass that all the way into the victim. And that's super cool, right? I don't know how that magic works, but I don't think it exists for C#. And if I'm wrong, like tell me, because that's awesome. But that leaves me with the problem is I need to be able to tell my C# where it's getting shellcode from, right? And it's not that big of a problem, because if you've written runners before, you're really getting it from one of 3 places. You're writing it on disk somewhere, you're calling the payload from a web domain, or you're embedding it right in the runner, right? So not a huge deal. I'll use the same 3 kind of premises for this tooling, right? The problem is that I'm not just going to be able to drop raw shellcode on disk, right? We're not just going to be able to call that over the wire. So we do have to encrypt it first. Makes sense. But the problem I have, the cart before the horse here, is like, how do I take shellcode that you encrypted and feed it into my tool and it just understands, right, how to decrypt it? So the first answer to this problem is I was just going to write an encryption module for the tool. I already had that anyway, right, for all of my tooling. So the concept is I'm going to write an encryption module, feed it the shellcode file, and it will give me back all of my different encrypted payloads. So like I said, I'm using Mythic and Merlin right now, so just grabbing the Merlin shellcode on disk here, and then I'm going to pass it in through my tooling GT inject, use the encrypt module, tell it where to find the shellcode, and tell it a multi-byte XOR string. So instead of a single byte, just if you have 8 characters in your string, it's going to go through 8 bytes one at a time and XOR it with that value, and then repeat forever. So a little bit better, a little bit harder to crack, and honestly, you can still get away with single byte XORs. So this is years down the road before they figure this out. So what you get back from the encryption module is base 64, XORed shellcode, base 64. I host that on my web servers if I'm going to do that. You get the XORed bin file. That's just your raw shellcode. Name it something stupid and drop it to disk. Or there's a text file, gives you a couple of different formats, gives you a C byte array, a C# byte array, so you can kind of choose what to do with it, like embedding it. So what that gives me is the encrypted shellcode that I need for now. I think I'm going to expand on this, more encryption options, but for now it gives me everything I need and it works well enough. So what that means is we finally have something set up enough that we can do process injection. And the way I decided to build this was essentially inspired by BruteRetel if you've used it. The idea is like the Panera upick2, right? So there's two different primitives that you select. Your memory option primitive and your thread execution primitive. I broke them out by call categories. So anything in the 100 series is like Win API levels. 200 series is NT API levels. 300 is syscalls, indirect and direct. And then 400 level will be like novel techniques. And so what that means is we can choose every time we inject. I might want to allocate memory with the Win APIs for virtual alloc EX and write process memory, but I don't have to call execution that way. I can tell it I want to use NT level APIs to execute it, and it'll just pass that memory address back and forth. So this kind of gives you pretty good like red teaming, purple team opportunities, and we'll get into that a little bit more, because by doing this, just already what I've built in is kind of like the bare minimum, and there's maybe 40 different combinations that you can achieve. And like, I don't feel like I've scratched the surface. Like going into it, I feel like there's a lot more traditional methods that I could implement, and we could still use this mix and match primitive. So we'll get into looking at that. But right now, I wanted to call out implementing syscalls was one of the goals of it, right? So I kind of wanted to talk about it a little bit, just so we can understand kind of what it meant for me. First and foremost, like I said, it needed to be portable, right? So if you look at some of your traditional POCs, a lot of them are written in C, right? So translated into C#, and there's some good articles on that. But it can't use static syscall IDs, right? It has to dynamically retrieve them because this has to be portable. So it references NTDLL in memory already. We're not reading it from disk or loading a second copy. We're just going to use the one there already. And then it retrieves those syscalls dynamically, kind of Halo's gate method, where it's saying, all right, you want this API call. I'm going to go check if it's hooked. And if it is, if it's not, we're just going to pull that syscall ID, and that's the one we'll use. If it is hooked, just increments to the next API function inside of NTDLL, right? And if that one's not hooked, it'll grab that syscall ID, decrement it by one to give you the correct syscall ID. So, I mean, it's essentially just an index of functions, right? So that's how we're dynamically retrieving it. When I was in my test lab for it, I decided to just kind of go that far and say like, okay, Halo's gate, that should be good enough for what we want to achieve. What we're looking at here is the test lab, and when I was in there, I noticed like Sophos, for example, hooks right away. First byte of the function call immediately jumps into the Sophos DLL. On the bottom, we can see the CrowdStrike hook. It actually doesn't jump right away. It does the first three, the move RCX into R10, and then it jumps on that fourth byte. So a lot of your POCs are reading up to 3 bytes, and then if you read up to 4 bytes, you can kind of validate that it's not a CrowdStrike hook, right? So it turns out that is Tartarus gate. Like that's the whole method, is just reading 4 bytes instead of 3, which is like the audacity of the person who published that, gave it like a logo and a GitHub page and like an article and a blog post, and like, I didn't even know, I just changed the line of code, right? Not even, I changed the integer, right, from 3 to 4. Like, at no point in my career will I ever release research that was like, I changed an integer. But this guy did, so good resume fodder. But that's what we're doing here. So this is the inject module. We're going to launch Notepad. We're going to see a little bit about how this works. So we're going to call the inject module. We're going to specify the 100 series Win API memory allocation and 100 series thread execution. We're going to give it the static string for the XOR key, and then point it to the shellcode, which is just going to be the embedded shellcode for now, and then give it the process ID. So start out by just launching Notepad, get a process we can look at. Call the inject module. You can see if the help module lists out the memory options that are currently available. I think there's more in here than since I recorded this even. That could be a lie. So down at the bottom, inject module, call 100, 100, the Win APIs. Calls those, and we can see just the message box pop up inside of Notepad. But the reason it's cool is now if we do that exact same thing again, I can just say, well, instead of 100 level memory option, I want to do like 303, I think we select, which is indirect syscalls to create a section in memory. And then I RTL create user thread, the NT API call to do the execution. And it's as easy as that to select another method and get the same execution, right? So now when I run this, I can, like I said, there's like 40 different combinations in here. And right out of the gate, now I can actually do something with like, hey, what works and what doesn't, right? The other big thing I noticed is APC injection, right? That, like I said, that kind of sucks in a lot of C2s. It just doesn't work the way you want it to. I took an opportunity to fix that. What that meant for me is I found success when calling a specific thread instead of just blindly shooting at a process ID. And so the way that works is the threads inside of a process have to be in like an alertable state, we'll call it. C# calls it a wait state. So I wrote a module for this called threads, and it literally iterates through every process you have access to, kind of like a process listing, and also shows you the threads inside of that process that are already in an alertable state. So we'll take a look at that and why that's important. So we're going to end up doing the same thing. We'll do indirect syscalls to create a section in memory, and this time indirect syscalls to QAPC thread injection, or whatever the name of the API is. So the threads module is being called right now. It starts listing out your processes and also shows you thread IDs inside of there. A couple of different wait states. There's like suspended processes. That's a wait state. We'll see PowerShell here just popped up. PowerShell has a thread in execution delay. I like execution delay. If we have time, we'll get into it, but we don't have to right now. So if I call that and I point it into the PowerShell process ID, that's going to be a process we inject into and also feed it the thread ID. So it specifically has that value. This works. This process injects now. This gives me APC injection, and this has been super reliable for me. I get one beacon back. It actually checks in. It works. This is kind of my go-to method now. Most of my engagements, this works. That said, everything we've seen so far is it's still traditional process injection, right? There's not really any novel research. Any blog post you read is going to show you these techniques. So within the past year or so, we've seen some novel techniques come out that are a little difficult to fit into the tool because the way they work and the reason they work is they break these primitives. So if we look at threadless inject, that's one of the methods right now. It's not executing a thread. It looks in a remote process's API call and essentially hooks it. So then we allocate memory in there, but you wait for that process to call that API naturally. So it's the one executing the thread. You don't do that. And that's why it works, right? But that breaks the primitive. And you see that with Mockingjay too. I haven't actually played around with this yet, but it is on my to-do list. You're not allocating the memory page, right? It's reusing RWX memory pages in a remote process. So once again, breaking that primitive. So how do I define that? Right now, thread pool party, that's big. I don't know if anybody's played with those ones, but kind of the same concept. Instead of, I haven't done as much reading on this, but instead of executing that thread, you're essentially finding out where the next thread is going to execute and then triggering that, right? So still writing to that location. Thread pool party is on its way. I'm currently converting it into this tool, but I have yet to find a public example of thread pool party written in C#. So I am doing a lot of data conversions. ChatGPT is doing a lot of data conversions for me right now, and I'm validating whether or not they work, and they don't. So from a novel injection perspective, I did implement threadless inject. It's two different threadless inject methods right now. Again, they'll probably get revamped a little bit. And this time, instead of just watching an example, I actually ran it through Mythic using the Merlin agent. So this is my test lab. This is the box running Defender for endpoint or ATP or whatever they're calling it until Tuesday. So we're going to grab an MS Edge process, feed that in. because it's a novel technique, it's a 400 series call, and right now they don't honor, like if you specify a memory allocation method, it doesn't care. It says I'm unique and I'm going to do my own thing. So it's essentially the threadless inject repo copied and pasted into this tool. This time is different. I'm calling the shellcode from disk just so we can see a little bit of a difference. Point it to edge, we get our beacon back from edge. It's a video, so I know it happens. There we go. So that's cool. Now I have a novel technique in here. It really doesn't ever get detected. And I have a lot of other options available to me in addition to this, right? And what that means from like a red teaming, purple teaming standpoint is kind of huge, right? It's the same process whether you're doing it for a red team or a purple team. It's really about identifying like what works in our environment, right? And the way I would recommend doing this, if you're going to try and use a tool like this, start a beacon in your environment, and then go use like a novel technique. Get into another process, make sure it doesn't get detected. It's not going to. Novel techniques, they haven't figured that out right. So get a new beacon, try other novel techniques, see what works, and then just slowly lower your OPSEC. Can I get away with like indirect syscalls? Can I get away with direct syscalls? Can I do NT level APIs? If you've got one of those EDR vendors, some of them are like really like butthurt about touching the kernel. They're like, you're gonna blue screen your entire fleet. And so they live exclusively in userland, right? This is a great way to show that. I keep using the APC injection method. I do it with indirect syscalls, and a lot of times that ends up working for me, and that's one of the reasons that some of the vendors I'm up against are, persistently in userland. The other thing to consider is like who your target audience is, right? Because the other thing I can do with this and have found is I might have methods that work against, say, Defender for endpoint. And then as I lower that OPSEC, they maybe still work. I still get a beacon, but now the dashboard shows a detection. Like, for example, medium severity detection is what it'll show you for some of your traditional primitives using indirect syscalls. You'll still get a beacon back, right? So if you're like a pen testing firm, you're doing gigs like this, maybe you don't care, right? Because I've certainly done tests for companies that don't even have an IT team, much less a security team. And yeah, so it goes off. What are they gonna do at 2 in the morning? Nothing, right? They're probably gonna look at it and be like, Defender doing its job, I'll move on. So you can find out what your threshold is for success, or what your risk threshold is, and what works, right? That said, there's a lot to add, right? Starting with just traditional primitives, the more, I don't know, in my head I just feel like, there's a handful of process injection techniques. And now the more I look into it, like I'm sending myself articles again for things I've never heard of and I've never used, right? So I think there's a lot of traditional primitives that I can add and just keep multiplying that availability of different mix and match options. I would like to get like a create suspended module in there so we can start doing like process hollowing options. Create a Mockingjay process is a good idea too, right? I could have a static process that's gonna load up an RWX page for us. Novel techniques, obviously. I wanna get Mockingjay in there. I think White Knight Labs has a couple of really good examples with a couple of different like sizes available of RWX pages, which is huge because Merlin is written in Golang, so the shellcode is like 8 megabytes, right? So I need something huge. I don't even think I can find one. It's gonna have to be like different. I'll have to use a different beacon. And then, like I said, thread pool party, I am working on that. I wish I had it available right now, but I don't yet. I think that's probably the next one I'll work on and get it in there. So that said, all of it is up on my GitHub right now. Feel free to use it. If you do, let me know. I'd love to hear what your results are, what you think. Like I said, I've used it. I've tested a couple of different EDRs, and I very quickly was able to identify like, hey, this works, this doesn't, this might work for me. It's been useful for me already, so I probably won't let the project die for like at least another year. So that's it. Any questions? Nothing. Right on. Cool. Thank you.